Evolution of computer architecture from the 0th to the 5th generation. Brief history. The history of computer architecture reflects progress from mechanical systems to highly intelligent AI-driven devices. Each generation introduces unique technological features, applications, and improvements over its predecessors. Below a detailed explanation of each generation's features and significance.
On the evolution of computer architecture based on the 0th generation. The 0th generation represents the foundations of computations. Devices like the abacus, Pascaline, and Charles Babbage's analytical engine relied on gears and levers. They were the first attempts to automate calculations, but were restricted by their mechanical nature, which limited speed and versatility. Examples of the 0th generations are the abacus, the Pascaline, and the analytical engine. Some characteristics of the 0th generations are, and I state, 1. These were mechanical computers rather than electronic ones. They operated without electronic components like vacuum tubes and transistors. 3. Relied on gears, levers, and manual operations. These are some key features of the 0th generations. 1. The mechanical operations. No electricity. Computations were performed using manual mechanical systems. 2. Limited functionality. Capable of basic arithmetic only, such as addition and subtraction. And 3. They were non-programmable. Predefined operations without flexibility.
First generation, 1940 to 1956. Vacuum tubes replaced mechanical components, enabling faster processing. However, these computers were unreliable due to frequent tube failures and high heat output. They were primarily used for military and scientific applications like trajectory calculations and business data processing. Example, ENIAC and UNIVAC. Characteristics: used vacuum tubes for circuitry and magnetic drums for memory. Large, expensive, and consumed a lot of electricity. Programming was done in machine language. 2. Key features. 1. Vacuum tube technology. Early electronic components used for logic and computation. 2. Programming in binary, machine language (binary), and low-level assembly language were used. 3. Large size and power hungry. Occupied entire rooms and consumed massive amounts of electricity. 4. Output or input via punch cards. Data was entered and retrieved using punch paper. Thank you.
The second generation, transistors computers, 1956 to 1963. The introduction of transistors revolutionized computing. These systems were smaller, more affordable, and suitable for businesses. High-level languages like COBOL allowed programming of business applications, making computers practical beyond research and military use. Example, IBM 1401 and PDP-1. Characteristics: replace vacuum tubes with transistors, making computers smaller, faster, cheaper, and more reliable. 2. Introduction of assembly languages which made programming easier. 3. Magnetic core memory was used for storage. Now, let's see the key features. 1. Transistor technology. replace vacuum tubes, making computers smaller, more reliable, and energy efficient. 2. Magnetic core memory, faster and more durable memory storage than magnetic drums. 3. High-level programming languages, introduced languages like Fortran and COBOL, making programming more accessible.
Third generation transistor computers, 1964 to 1971. Integrated circuits brought a quantum leap in the processing power and reliability. Modular design like the IBM System 360 introduced scalability, making computers a standard tool for business, research, and education. The introduction of systems allowed more sophisticated and efficient use of computer resources. Examples of the third generational computers include the IBM System 360, DEC, PDP-8. Some characteristics of the third generational computers include the use of integrated circuits, which allowed for more components to be packed into a smaller space. Introduction of operating system that allowed multiple applications to run at the same time. High-level programming languages like COBOL and Fortran became more common. Some key features of the third generational computers include 1. Integrated circuit, miniaturized circuits for thousands of transistors on a single chip, improving speed and efficiency. 2. Semiconductor memories. This enabled faster access to data. 3. Operating system. This supported multitasking and time sharing, allowing multiple users to access the system simultaneously.
Generation 1971 to present. Microprocessors marked the beginning of personal computing. Companies like Apple and IBM made computers widely accessible. GUIs simplified user interaction, while networking and the internet enabled a global exchange of information. Innovation in portability like laptops and smartphones further transformed everyday life. Examples: Lartey 8800 and Apple and IBM PC. Fourth generation characteristics. 1. The development of microprocessors which integrated the functions of a computer's central processing unit onto a single chip. Personal computers became widely available, leading to the rise of home computing, graphical user interface, and networking capabilities emerged. 2. Microprocessors. The CPU was integrated onto a single chip, enabling powerful yet compact computers. Networking and internet enabled connectivity, revolutionizing communication and data exchange. Personal computing. Affordable PC brought the computing to homes and small businesses.
I'm here to talk about the computer architecture of the fifth generation. The fifth generation computer system was a Japanese funded project that was aimed to develop a new generation of computers. The fifth generation system focused on intelligence and efficiency. AI powers applications like smart assistants, which you have like Alexa, and robotics. The fifth generation computer architecture focused more on artificial intelligence, AI machine, and learning natural language processing. The key concept of the fifth computer architecture was based on parallel processing. The parallel processing is for the computer to perform tasks concurrently, and also logic programming, the use of logic programming language such as Prolog to develop artificial intelligence. And we have the natural language, which enables computer to interact with human speech.